So welcome again to our Customer Insights webinar session of May. So we are set up. And also I'd like to share that this webinar will be recorded, and we will send you the link to the recording after the session. It will be available also in our YouTube channel, so you can share it to your colleagues and watch it yourself again if you want. So that's something good for you to know. I'm your host today. I'm Riina. I'm the product marketing manager at Solibri, running these customer insights webinar sessions. We also have our customer success manager, Lauri Luoma, online. Lauri can help to answer any Solibri related questions you might have. Hi, Lauri.
Hello, everyone. Hey, I'm going to help you with the questions, possible questions in the end of the webinar. Looking forward to today's presentation.
Absolutely. Thank you, Lauri. So the agenda today, we have case reaching partners, a case about digital fire compliance reviews. This is an award-winning digital approach of Reach to demonstrating the Firestop compliance. So it will for sure be interesting to hear how they have done this in their company, and hopefully you will get a lot of good tips and pointers on how these type of things can be handled. Like Lauri already mentioned, we will have some time in the end for audience questions. So at any point of the webinar, you can send your questions to the chat or the question box, and it will help us a lot if you can kind of mention who your question is for. If it's for Brent or Alex from Rich, or if it's for us, so that Lauri, for example, can help in answering it. And now, before we go to the actual presentation, we would also like to ask something from you to get a little bit acquainted with our audience. Our poll this time is about, well, the same topic as the presentation is. So how is it with your BIM projects in your company? Do you require fire ratings to be included in the BIM models? And I can already see answers coming in, so I'll give it a little bit more time for you to reply. So far, it seems that maturity has replied yes sometimes, but let's see how this evolves here. All right, it's looking like most of you have given your replies, so I will now close the poll. Thanks a lot for your replies. So let me just share the replies. So as you can see, over half of you replied that yes, sometimes, and then the rest goes pretty much half and half. So I don't know, maybe for the people for whom it's not required, maybe you get some tips also on that maybe it would be good to require it in the future.
Yeah, I think it's interesting to see that result come in. I think that reflects some of what we're going to talk about.
Yeah, great. So actually, yeah, without further ado, so we have Alex Plenty and Brent Rees from Rich here today. Welcome so much. It will be great it's great to have you as our speakers this time. and I'll give the floor to you. Let me also give you the presenter rights print so you can get started.
Sorry, I'm going to share my screen. There we go. So that should be sharing now. Oh.
Yeah, we see the PowerPoint now, not the presentation mode though, but
No, bear with me. I'm just about there. Okay.
now it looks great. Yeah, thank you.
Sorry,
Go
I'm
ahead.
just trying to close this. Okay, so good morning all, or good morning to those in the UK at least, and good day, good afternoon to those joining from elsewhere in the world. Thank you, Rena, thank you, Lowry, for inviting us today to come and speak. We're going to talk about digital Firestop compliance reviews and how we can utilise Solibri to do that. Just a point, there are a few QR codes dotted around the presentation, which you can use your smartphones to activate and follow and access web pages and or associated documents which might be useful. So my name is Brent Rees, and I'm a partner and I lead the digital engineering team for the business. And Alex, who's going to speak a little bit later, is a BIM manager within my team. Ridge & Partners are a multidisciplinary property and construction consultancy. So we have primary construction consultancies services like architecture, engineering, project management, quantity surveying, building surveying, and so on, and peripheral kind of specialist services, including ours, geospatial, sustainability, and so on. We were established 75 years ago this year, in 1946. We are now 600 plus people, approaching 650, I believe, with about 200 of those in our HQ in Oxford, but the remainder spread across 11 other UK offices. And we pride ourselves on approximately 80% repeat business. So what I was going to talk about next was our the work that my team do. So as part of the digital engineering team, we split our services into four key areas. So one is information management, where we support client organizations in development of requirements. We implement accommodation environment platforms. We support teams through delivery of Kobe. We also provide BIM coordination services, where we receive models from design teams. We review those in Solibri and or other tools were required, but preferably Solibri, and provide feedback to teams on the design and coordination status of those models. Fire compliance reviews, or Firestop compliance reviews, which we're going to talk about in more detail today, and 4D programming, where we apply construction programs to models to simulate sequences. And we do that across the UK for clients, owner operators, consultants, contractors, facility managers in some cases, on projects across all sectors at varying values. We also support the business's BSI BIM certification on an annual basis. In the bottom corner is a link to our digital engineering brochure, should anyone be interested. So I'm going to talk today, I'm going to talk through some of the basics of fire stopping and the complexities of that, and why changes in UK legislation or industry guidance have brought a renewed focus on the issue of fire stopping. So I'm going to go back to basics on some of these things just to kind of build up the narrative throughout the slide deck. So fire stop terminology, first of all. So the first phrase that we'll probably refer to quite often is builder's work opening. So being clear about a builder's work opening being an opening either in a wall or a floor to allow typically building services to pass from one space to another, or from one level to another. The fire stop, which is a product which is used to then fill that opening to maintain the fire rating or the fire resistance performance of that wall or floor. So if a wall is designed to withstand fire for 30 minutes, then the product filling that will maintain the same for 30 minutes. Service penetration, so where the services passing from one space to another pass through the wall and or through the fire stop. So service penetration, quite self-explanatory. Service spacing, so the gap between multiple services that might be passing through the same fire stop. So it's quite critical to understand that point, and we'll come on to that in a bit more detail. And aperture spacing, which is the distance from the edge of services to the edge of the builder's work opening or the edge of the fire stop. So we'll refer to these phrases over and over again through this presentation. So to add a bit more, apologies, to add a bit more detail to this, so we're going to talk about the complexity generally of fire stopping in the design and construction space. So anyone who's worked on a construction project will recognise that the design and specification of fire stops can be a difficult process, and often this can be quite difficult at the compliance end of the compliance and handover end of the project. So really we're thinking about who in the design team is actually responsible for designing and specifying. Is it the architect? Is it the MEP engineer? Is it clear who should be monitoring compliance throughout the project? And then thinking away from fire stops about builders work openings that I mentioned earlier, who actually designs and approves the location and size of those, and then extending into building services dampers where they're required. Whoever carries out that activity, is their professional indemnity insurance adequate for them to carry out that role? As I touched on earlier, who's responsible for monitoring compliance through construction, because there's kind of multi-party involvement for the installation of these things. And then actually, what does the client or the owner-operator receive at handover in order to understand the number of fire stops in the building and the manufacturer and the product type that's being used in every instance? Questions, not necessarily answers to be answered right now. Adds to this that in the UK we have a suite of kind of legislation documents called the building regulations approved documents, and part B of those approved documents deals specifically with fire. And for many years now there's been a requirement within that wherever a fire stop is used, or a proprietary sealing system as it's referenced in the approved documents, it needs to be shown by test to maintain the fire resistance of the wall or the floor or the cavity barrier. So whilst that sounds quite straightforward, we need to recognise that actually fire stop manufacturers have only tested a finite number of instances and configurations, and the design and construction process will often come up with a myriad of non-typical or bespoke scenarios and arrangements of services passing through a fire stop or a builder's work opening. So whilst it seems a straightforward requirement, it's not quite as straightforward as it may seem. So to bring that into focus a little bit more, I've come back to this diagram again. But there are a few different factors that drive whether or not there is test data available for that particular scenario. So first of all, the fire stop that's selected to fill the opening will be subject to different test data. The next, the material and the size of the service passing through that fire stop will be subject to different fire test data. So a copper pipe will perform quite differently to a plastic pipe, and will perform quite differently to a galvanized cable tray, for instance. But those three things will drive how far apart the service spacings need to be and how far apart the aperture spacings need to be. So the distances between services and the distance between services and the edge of the fire stop. So you can see that there's tiers of complexity of achieving that requirement in Part B of the building regulations. But add to that through construction, I mean, even through design, but through construction as well, there are multiple parties responsible for coordinating this item. So if you think about in construction, there'll be one party that will construct the wall and therefore the builder's work opening. There will be another party that constructs the building services and is responsible for spacing those, and then there'll be another party that comes along and installs the fire stop around into that builder's work opening. and then think about actually what's given to the client or the responsible person at the end of the project to continue to maintain and understand each instance that's applied in their project. Add to this complexity that in recent history in the UK, the Grenfell disaster has brought, I mean, primarily a renewed focus on cladding, because of the issues associated with that disaster, but it's actually brought a renewed focus on the design and specification of all systems related to fire safety. And as a result, has had an impact on the professional indemnity insurance market in the UK as well. So it's as I said, it's brought a renewed focus on all sorts of things related to that, but also a renewed focus on Part B of the building regulations, and that item I said about the proprietary sealing systems being shown by test to perform for the required period. And one of the spin-offs that came out of the Grenfell disaster was the publication of the Hackett Report, and there's a link in this page to review this, which made some which concluded with some findings about the state of the industry at the time, and made some pretty significant recommendations about things that should be carried out moving forward. But it used phrases like ignorance associated with those working in the industry about the understanding of the rules and regulations, indifference in part of the industry about delivering projects quickly and cheaply rather than to a high quality and safely, limited clarity on roles and responsibilities of the industry, and inadequate regulatory oversight and enforcement tools. So a recommendation about forming new bodies that oversee the approval of buildings at the end of at handover. But one of the key recommendations within the Hackett Report was that for a golden thread of building information, so referenced informally in the industry as the golden thread. And what that recommendation suggests is that a digital record, as it's referenced in the Hackett Report, is collated throughout the project and given to the client or the responsible person at the end of the project, and it's thought that that's going to be underpinned by a BIM process or a BIM approach. And so whilst it doesn't explicitly state what that means, it clearly makes suggestions of where that's going to be, and it also clearly places responsibility on the client or the responsible person or the duty holder to initiate that process and to hold and maintain the information throughout operation of the building, which is a bit of a shift from where we've been prior to the Grenfell disaster. So I think it's interesting, this point. It's clear that it's had a ripple effect on other bits of legislation and industry guidance that have come out since, such as the draft building safety bill and the construction playbook. And if we reflect on the level 2 BIM mandate and the effect that had on our industry to promote cost savings and efficiency from projects and operation, then I think the recommendations of the golden thread, with an effort to drive safety and safety for occupants in our buildings, is going to be a bit like a stick compared to the level 2 BIM's kind of carrot, for want of a better analogy, and I think will have deeper effect in terms of driving BIM adoption and digitalization of an industry generally. So jumping in then to a digital approach and thinking about how we can better utilize tools and data to manage Firestop design and specification generally, and giving information to clients at the end. So some years ago, we were working on a large automotive scheme with a large tier 1 contractor who have a preference for using precast concrete, which may suggest who that is. And at the time, because of the nature of precast concrete being designed and finalised much earlier in the process than some other techniques, we had to have confidence in the number of builders work openings required in the project, and that the size of the builders work openings were going to be appropriately sized for the services to be spaced for the Firestop product to be compliant. And when we were posed with that challenge, at the time, we didn't have a clear plan for dealing with it, and this is where our kind of thought process and our kind of approach to this was born, and we developed that over a number of years, and I've subsequently been fortunate enough to win a couple of awards for this process. And so I'm going to talk through some of the key kind of thoughts that feed into the development of this process. So the first is thinking about product. So thinking about the manufacturer of the firestops to be used in the project, the short list of that manufacturer's products to be used, and therefore the test data that needs to be complied with. And this is really important because it gives you the kind of ground rules for the service spacings, the aperture spacings, and therefore the size of the builder's work openings. So it's really key to do this early, because the test data, which is required as part of the building regulations in the UK, is important, but it will also vary from manufacturer to manufacturer. So not only is it key to make those decisions earlier in the design process, it's also quite important to nominate the use of that product into the main contract, so that the decisions taken through design can be carried through into construction and there isn't any kind of abortive rework, so that there is potential for less competitive tension as we move into construction, and better kind of value in purchasing Firestop products. But with this approach, we can also demonstrate a compliant design earlier in the process. The next point is thinking about data that's added into models, and this comes back to the poll that Rena posed at the start of this presentation, and thinking about adding fire rating information into models. It's key for the way we work, and Alex will touch on this in a little bit more detail about being able to find the fire rating of model information, and we'd advocate that that's placed typically into IFC parameters, so that the rules can point at those and find those quite quickly. But in terms of a process, we'd also advocate that designers place a fire rating value in that parameter, even if it's even if that element isn't fire rated. So if it isn't fire rated, putting a 0 in there, so that we have a level of confidence that all fabric within the building has been considered. And as well as fire rating information, adding the material information into building services, so that we can define or find copper pipes, or define copper pipes from plastic pipes, for instance, within a project. The next key part of this process, we think, is actually defining a robust process for builders' work openings, so modelling those, and actually defining with the team if there are any minimum dimensions above which builders' work openings will be modelled. Is quite a common approach, but we think it's actually maybe better to define that minimum dimension at earlier stages, so at RIBA stage 3 perhaps, but moving into stage 4 and certainly stage 5, actually modelling every single builder's work opening in the project irrespective of minimum dimensions. Agreeing who's going to position those early, so initial thoughts are, from our perspective, that perhaps the MEP engineer takes responsibility for placing a model element as a builder's work opening request, and that the approval or the acceptance of those is only given once the architect or the structural engineer has reciprocated that by cutting an opening to reflect that in their own model. And then thinking about how that void is filled in the model, so placing a model element back into the opening to fill that void, and the benefit that gives you then is something that can be scheduled, either in a typical Revit schedule, or thinking about extracting that as a COBE component item. So how this works then is we sort of see this as an extension of what we do with BIM coordination rules, and Alex will talk a bit more about that, and overlaying that with information management principles. So we'd usually start with a kickoff workshop with a team, ask them to update and upload their models. We federate and review those within Solibri, and we analyse fabric openings and spacings. spoken about before, we feed those back as issues to the team, and usually push those into a product like BIMtrack, and then we go around and do that process again until we get to a point that we're confident that the vast majority of the instances of builders work openings and fire stops within the project are compliant. And as I said, the end goal, certainly if we can do this through the design process, is to schedule every single instance of builders work opening and fire stop required in the project. And I sort of hinted at getting the vast majority to demonstrate compliance, because in some instances it may just be impossible to select an off-the-shelf or proprietary test data to align with a configuration in a project. And so those instances need to be kind of itemized separately and escalated back to the Firestop manufacturer for independent engineering judgment. And even that, still significantly reduces risk, and a contractor would be able to add a contingency sum against each of those, recognizing and the risk associated with each. It's better to know how many you don't have test data for than to not know at all. So by adopting this process, we have an opportunity to then output each individual instance of a Firestop as a line within the component tab as part of the Kobe deliverables, which is a shift change and sort of starts to better align with the thought process of the golden thread. But we also, if we're validating or making compliant design through design, through the models, we can overlay point cloud data from site directly onto those models to demonstrate compliance from the desk. And we have an opportunity also to asset tag alongside the fire stops to provide a link between the physical asset and the digital data that's contained about it within the Kobe dataset. So just to summarize a few points then. So I've put the RIBA plan of work stages on the side there, and conscious that perhaps that's not applicable to all that are on the call, but thinking about where it sits within a process. So thinking pre-design, supporting our clients to understand what their obligations are, certainly with the implications of things like the golden thread. The appointment of an information manager to support these processes and advise the setup of other key documents as part of a BIM process. So defining requirements early, checking the capabilities of supply chain as they're coming on, implementing accommodating environment platform, and thinking about, is that actually a project resource, or is that actually the client's resource moving forward, so that it facilitates better transition and handover of information at the end of the project, because it's all being exchanged within the client's environment anyway. I can see that being a bit of a shift in the industry in the future. And then checks on PI insurance, because post Grenfell that's becoming a more and more contentious aspect of the industry. Through the design part of the project, so starting spatial checks early, agreeing the short list of products in which manufacturer are going to be used, so that you can use those rules to guide the sizing of builders work openings, using a digital BIM enabled process so that all the project's fire stops can be scheduled, and any non-proprietary or non-compliant issues can be escalated back to the manufacturer. And then using those outputs through the construction process as a quality control measure, using other technology and processes to better validate those at the end and provide better deliverables. Thinking about the deliverables the client's going to use. Is it a Kobe data set? Is it a model? Because a model isn't always the right answer. Is it a drawing of each instance? Is it the schedule? Is it all of those things? And where they're going to reside through operation, I think is valuable in guiding client teams through the use of those. And so finally from me then, just I touched on the Grenfell disaster, and this Firestop compliance issue isn't just a high-rise residential building issue. We're seeing with changes to industry guidance that actually this is going to trickle out into all buildings in the industry. This process has the opportunity to better tailor the scopes of consultants working on projects, better define their responsibilities, and better protect their PI, because we're better thinking about Firestop compliance earlier on. Significantly reduces risk of contractors, and gives better quality and better accuracy on tender returns. It gives the client a much better deliverable at the end and a better understanding of where the fire stops are in their project. So if they choose to refurbish a space in the future, they know what they need to replace that with. And then thinking about all of us as occupants of buildings, in the future we'll be living and working in buildings that will hopefully be safer places to be. And so that's enough from me for the time being. I'm going to hand over to Alex now, who is going to show us what some of these things look like in Solibri and talk about applying the rule sets elsewhere.
All right, I'll share the screen for Alex now. Looks good. Go ahead.
I was muted. Sorry, that might be better. Thank you, Brent. I think you painted a good picture of what the process is, and so let's have a look at what it looks like in Solibri. So I've got what looks like a bungalow here. It's not a bungalow, I promise. So it's a test project that we use, and it's basically one floor of a high-rise building just sort of cut out and then exported from Revit in this case. And just to give you some context of what these Firestops and Builders Works might look like. So within the building, if I just drag the section down, you'll see each individual apartment here. So at the entrance to each of them, we've got services coming up over the door. And it's here where we've placed these red boxes, which are the fire stops. And it's within these red boxes that we test the distances between the components and the distances between the aperture of them as well. In some instances, we've put these builders works in as well. So you might have these where there might not need to be a fire stop, or you might have it in a process where we're just thinking about openings. We're not putting fire stops in just yet, so there might be earlier fire stops. So that's what it looks like here. So if we go to one of the issues that the rule sets has picked up, it will show you a bit better of what the output is. So if I zoom in here, and I'll just get rid of the section as it's making everything a very blue color, looks like it's under the sea. So within the fire stop itself, we can see very clearly there that this pipe here is only 4 mil to the edge of the fire stop, where it needs to be 10 mil to the edge. So that will depend on what sort of pipe it is and what test data is being used and what product's being used. But for this product that we've used on the test project, that's what it needs to be. So how does this look like in other scenarios? So I've picked up a few others of what other issues I raised. So we can test when there aren't builders works or fire stops in. So we can test the distances between the components, but we can't really test the distances between the aperture of the opening, as we don't have the opening in yet. But it is good to raise these earlier stages so that we can builders works can be started to be placed. Got another example here, 2 pipes that are too close to the top of the opening. Got another one here where the pipes are too close to each other within a fire stop. And then lastly, we've got a cable tray here that is too close to the top. And as Brent mentioned, we can also schedule these out. So I've got a very simple schedule here. So I've got 2 fire stops in this model, and my schedule just tells me a unique name for these. You can put a manufacturer in, you could put the name of the product that's been used and sort of the description of how the fire stop has been made. And then you could put these into a site issue management file like BIM 360 or PlanGrid or something, and then on site you could sort of do a pre-fire stop check and then a post-fire stop check, and you could take pictures of an iPad or whatever you want to use in terms of that sort of compliance. Another thing Brent mentioned was you can track these in a COBie data set, and so this might be good for standard information exchange for a client, an end user, who could then translate these into the job tab within COBie to start tracking, whether they're tracking the compatibility of these fire stops every year, or every 2 years, just to make sure that they haven't degraded or anything like that, or anything's changed. You can also do that within the COBie. So I'm just going to switch to a few slides that I have to talk about how it works and how we can recreate, how we can use Solibri rules, and then how we can use these rules to produce the fire stopping rule sets. So as Brent mentioned, the first thing we want to do is know who the Firestop product manufacturer is, and of those products, which ones we're going to use. So if we can narrow it down, that's going to be great, because we can then narrow down how many rules we're going to have to test. I guess it's really important at the start of a project that you're using the most up-to-date test data as well. And then what we're checking is the clear areas around services relating to what kind of service it is. To do that, though, we need to be thinking about whether these services are within openings and fire stops. But we can do that within before openings have been made, and just testing within fire-rated elements, as we mentioned. And of this, we get our output, so we get our issues that we mentioned, and then the COBE that we mentioned as well. So a bit of background about rules in Solibri. So one of the ways we can use rules in Solibri is just to use the out-of-the-box ones that come within the libraries. So if you have Solibri Office version, there's a rule set manager, and within that there's a window for the libraries. And one of the most common rules you'll find in this, in the libraries that you might have seen, is the general intersection rule, which is a fancy title, but what it means is it's clash detection, basically. So it's two model elements touching each other. And we can use this rule to layer and filter this rule to create something a lot more complicated. And this will form part of how the Firestop rules work. So we've got something that we want to itemize. So I want to itemize all of the services clashing with other models outside of Builders Works, so the electrical, mechanical, public health stuff clashing with maybe architectural walls or structural walls or slabs outside of a Builders Work, so needs a Builders Work. And we might want to, we might be told to itemize this because we might need to create a list of issues for an MEP services engineer to then, for them to then put the openings in the model. So the first thing we're going to do is we're going to filter our generic rule here to check for clashes within services against walls or slabs or other model elements. And it might look like this. So we've got building services against architectural and structural models, excluding Builders Work. And then we're going to layer it up with exactly the same rule, but filtered in a slightly different way. This time to show Builders Works clashing with services. And then we're going to make sure that only if it passes this test will it then go on to this rule to then itemize our output. So we can do that within the sub rule options within Solibri. Now, if we wanted to have exactly the same thing as this, but check for clashes within Builders Works, so maybe these might be a list where it might begin to an architectural structural engineer to approve the size of the opening. Maybe the opening's too big and it reduces the structural integrity. Maybe the opening's too big in an architectural piece of model element and it doesn't look very good, or it affects the integrity of that wall. Well, it's very easy. All we have to do is use exactly the same rule set, but just change it from passed to failed, and we get exactly the same thing. So it's quite simple to take a very simple rule and then just layer it up and filter it and to create something a lot more specific. So how can we apply this to the fire stopping rule? So if you have a look at the Rockwall test data, or any fire stop test data, but I picked the Rockwall one for this example, it's quite complicated, at least to me anyway. So we need to break it down in order to then start filtering, applying the out-of-the-box rules and start filtering them to get what we need. So the first thing we need to do is we need to, as Brent mentioned, we need to narrow down the products and the fire stop manufacturer that's being used. So in this case, we've got this scenario at the top. They have lots of different other scenarios. Some of them are more complicated, some of them less, but hopefully this will give you the bones of the process. So the first thing I'm going to look at is the type of service. So whether it's a cable tray, whether it's a ladder, whether it's a cable, how big it is. And then these are the distances, free areas that you'll need between these services, as shown here. So I'm going to have a simple rule here that is service separation by service, just one of the out-of-the-box ones. The next thing I'm going to look at is the fire rating of the wall. So it matters what the fire insulation is on these services. So we will put in some rules to start with to itemize clashes between fire rated walls and the services, and then narrow down, is it a 30-minute, is it a 60-minute? In these cases, it needs to be 120/90, 120/60. Next thing I'm going to do is look at the aperture size, so the size of the opening. And to do this, I'm going to filter these two rules to make sure that it's only including builders works or fire stops of this aperture size. And then next, I'm going to look at the aperture edge separation. So this one, it says 0 mil, but not all of them are the same, depends on the product. And this is the distances between the service and the outside of the opening. And to allow for this, all I'm going to do is I'm going to put another rule in parallel here as a sort of a child relationship to these rules, which is going to detect the distances between the apertures as shown in Solibri. So that's it for my slides. You're welcome to contact either me or Brent through email or LinkedIn or anything else. But we'll get to take your questions. I'll hand it back to Rena.
Thanks so much, both of you. Really interesting presentation. Yeah, we already have a couple of questions that's come in, and we can start going these through. And please, if you have any further questions, anyone online, just send your question to the chat. And if it will help if you also write, is it if your question is more for Rich, for Brent or Alex, or is it more general Solibri related, where Lauri can help then. But let's start going this through. So the first question we got is that, are we at the point where clients are asking for these checks regularly? Maybe.
Good question. Yeah. So in some respects, yes, I think clients are starting to recognise the risk associated with fire stopping generally, and the potential to get to the end of a project, to the handover point of a project, where the design, the specification, the installation of fire stops perhaps hasn't been very well considered. And there are reports in the press of buildings that are at the point of handover and have had to retrospectively pull out fire stops and rework service spacing. So because of that, and because of Grenfell, I think it's the awareness is increasing in the industry that this has to be reformed. Where we're seeing the biggest uptake, I think, at the moment, rather than end clients, is with contractors who recognise that they inherit quite a lot of risk through the tender process if the design and specification of the fire stops hasn't been well considered in the stages running up to that point. But it's clear that there's going to be a shift, and much like with BIM requirements, I think we saw contractors as early adopters with that generally, and that driving a lot of adoption in the industry first, and now we're seeing more and more end clients. I think it's the same with this. I think contractors are seeing that there's value in this, and they can limit their risk, and clients will see the same and be asking for it more and more in the future, I think. Good question.
Thanks. And there was also second question, what are the barriers to implementing this effectively? Continuation to that.
Yeah, good question as well. One, if a robust BIM process has been implemented, obviously, 2, potential adjustments to scope is a bit of a challenge and a bit of a barrier. So, we posed that question in the poll at the start about adding fire rating information into models or material information into building services. If that wasn't part of the scope at the start, in the design and scope at the start, then there may be some contentious items related to that if this is implemented as a later process. But I mean, if it's implemented at the start, it's written in the requirements, and the supply chain are clear what's been asked of them, and they're able and capable to do it, the barriers should be relatively low. I think one of the challenges is getting the right levels of engagement from Firestop manufacturers can also be a bit of a challenge. But the companies that we've engaged with, like Rockwell and Hilti, have very good and capable technical departments that are very responsive that can help.
All right. Thank you. Let me see what was the next question. There's a lot of questions coming in, so that's nice. Nice to see. So, question for Rich. Is there sufficient flexibility within the software and process to manage changes to specification, specifically a change in product or manufacturer at a later design stage when the project has already been reviewed against an alternative product?
Yeah, another great question. I'll let Alex answer this one.
It's a great question. It's a bit of a tricky one. I think the answer is yes. I think if you, when checking for this, it's a bit different from whether you're checking, standard sort of, I don't know, COBE or building regulations. Things that are static. It will change from which product manufacturer you use and what products within it. So at the start of each project, we'd have to sort of have a good look through the rules and tailor them. It's more like the process would be the same, but the products would change, so the rules would have to change. So I guess in the same vein that if maybe if a client suggested some products and then we tested those, and then a contractor came on board and wanted to use a different sort of products, then we would change the rules to do that. So it wouldn't be ideal, but we could definitely do it, and they're flexible to do that, definitely.
Okay, thank you. Then there's a question: have you been doing this on existing buildings or just new builds?
Another great question. No, we haven't been doing it on existing buildings, and there are challenges associated with existing buildings related to understanding the fire rating of different construction elements and construction fabrics. So, which can often require intrusive surveys if there aren't very good fire strategy records about the performance of different walls and floors. Not impossible, but it's reliant upon, like I said, either having really good fire strategy information, which defines the fire ratings of walls and floors, or a good model that contains that information. So, whilst we haven't, we're hoping to in the future.
Yeah, great. Thank you. Okay, then there's a question for you guys as well. You mentioned 3D model is not always the best solution. Can you give scenario examples?
Yeah, okay. So I think in that context, I was thinking about deliverables for the client organization to use. And so I think when most of us, myself included, we think about a BIM process, sometimes we default and we think about models, because models are an intrinsic part of a BIM process, but aren't necessarily the best or most useful deliverable for a client at the end of the project if the client doesn't have the capabilities or the tools to use or view those models at the end. We're seeing that changing. We're seeing client organizations increasing their skills and their capability to use them. But actually, other deliverables like a schedule of the fire stops in the building, like a COBE deliverable which itemizes the instances, might be more useful. It might be easier for a client organization to use, or a drawing of each one. I think it's just understanding what we're delivering and making sure that's appropriate for the client organisation, really. So yeah, good question. I'll be careful to be a bit more careful about that statement in future.
Okay, thank you. Then there's a question for Alex. How is Kobe used exactly to visualize the results produced by the rule sets, or what do you use it for?
It's a good question. So I guess it would depend on how you deliver Kobe. So when we deliver it, we would deliver it through models, through like a .ifc model, so what's called step physical file format, and that would mean that when a model element, a Firestop in this case, is within the Kobe data set, there's a direct link between the spreadsheet that would come out of it and what is in the model. So like I showed in Solibri, you could click on the component tab, and then you could click on the Firestops to see, where they are in the building, they're related to a space. When you're talking about them in a spreadsheet format, so if a client can't use the step physical file format or a model, you could then take the schedule of these Firestops, whether you've got 10 or 1,000 in a building or whatever they are, and see what space they're in, and then start applying that to the job tab, where you'd sort of build up your maintenance schedules for the end user. So hopefully that gives an idea.
All right, thank you. Then back to you, Brent. You mentioned both PI insurance and responsibilities in your slides. Have you seen examples where architects are taking ownership of the modeling of builder work in stages 3, 4? A lot of evidence at the moment suggests PI insurers will not allow or cover this.
Yes, so that's a good topic too. So it does vary wildly at the moment, dependent on the organisation and the organisation's appetite to do the work, which I think is really why it's quite important to align the scope at the start of the project and make sure that PI cover is appropriate. Because of this exact reason, it's perhaps if a barrier question was mentioned earlier, this is potentially another barrier as well. If we're trying to implement this process retrospectively on a team, if the PI isn't adequate in order for them to do it, then we have to think about other mechanisms for doing it. So, there is PI cover available to do this work. It's just a changing landscape, and the value of cover is diminishing, or some organizations can't get cover at all. So it's really one of those questions that needs to be asked early and checked early. And if an architect or lead designer's PI cover is not adequate to carry out that work, then another plan needs to be put in place, like the appointment of a sub underneath them in order to carry out the work on their behalf, for instance, and using their PI to deal with it. So yeah, so lots of thoughts around that.
Yeah, great, thank you. Then next question. Of course, the architect and structural engineer will model the builder's opening, but who should model the firestops in your opinion?
Good question as well. I have got an opinion, and I think, in my opinion, it should be the architect. And there's probably a lot of architects on the call who would passionately disagree with that point of view. But I think as lead designer, who's trying to coordinate the fire safety of the building through the design stages, it should be they're responsible to design and specify them, in my opinion.
Yeah. Then we have a question. Would classifications be a good approach to allow for greater flexibility of manufacturers or specifications? I wasn't sure if this...
I'll take that one, that's fine.
Yeah.
Yeah, thanks for your question, Max. That is a good question. We do use some classifications. I guess that's a bit we didn't touch on. So I think with Brent touched on it a little bit, of what sort of model information you'd need in the models, and particularly in terms of fire rating, it's it's a right pickle, because in Revit, which is sort of one of the primary tools in the UK, you have a fire rating parameter which doesn't export straight into the IFC, so you've got that one barrier. But then the other barrier is then, what do you put in that fire rating parameter? Do you just put 60? Do you put 60/60? Do you put 60 minutes? You know, that's the bit that's up for debate. So I think in the IFC specification it says refer to, you know, your country specification. I think that's BS 999 in the UK. I hope I'm not correct on that, but there's people furiously googling there. It's still ambiguous to what you put. So a good use for a classification is to say, if it has, you know, the 60 and then a 60 as well, then it doesn't matter if they've put a slash in between it, doesn't matter if they've put a space in between it, doesn't matter if they've put the minutes. You know, you can definitely use the classifications to standardize what you've got. And it's also, you know, a good way of controlling what you've got, because if you've got anything like your question alludes to outside of the test data, so, you know, if somebody's got a duct in there that's X number mil by X number mil that isn't being tested for, then you can say, look, this has fallen out of the classifications, you know, we're not going to include it in the rules until, you know, we're not going to include it in the rules, so it's going to be itemized separately for that engineering judgment. So, you know, the classifications are a good point, and it's probably something I should have put in the presentation, but we've covered it anyway in the question.
Thank you. Then I guess this is maybe related to what we were talking about before with you, Brent. So FM can be done without having access to 3D models in the future.
Well, it's probably more a reflection of where the FM industry is now. I think so. You know, the delivery of a COBie data set is, because it's easy to manipulate, it's easy to use, it's easy to because it can be exchanged in a spreadsheet format. It can be utilized by more people. It can be exchanged and used in different platforms. So that's kind of the thought process around, you know, why the government mandated the use of a BIM process to deliver a common standardized data set that's easy to manipulate and use. The FM industry is probably on is probably a couple of steps behind the construction industry, I think, in terms of BIM adoption and BIM understanding generally. I don't think it's unfair to say. So the long-term game and the long-term kind of ambition of the FM industry would be that, you know, they are better utilizing models, and there will be, you know, facility managers in the country and in the world that are using model data to their advantage and are using geometric models to understand where things are in a building. And there are definite examples of that, but that's not true for all clients. And I think that's part of the evolution of the FM part of the industry, is that they will start to better use models and geometry and the data associated, and will eventually have the capability to update those as you know, ad hoc changes are made to the project and the assets within them. It's a good question.
Thank you. Yeah, then there is a new question that would you get an IFC model from the subcontractor that would replace the fire stopping components on the architectural model at REPA stage 5?
Again, I think that would be a nice kind of next evolution of where the industry could get to. Again, a bit like the commentary around the FM end of the industry. I think the Firestop part of the contractor supply chain probably don't have the greatest BIM capabilities generally. That's sorry, the Firestop contractors. That said, we know that the Firestop manufacturers do have some pretty good strength and depth in that space from the conversations we've had with the likes of Rockwell and Hilti, for instance. So I think in terms of what we get from the subcontractor, that would be perhaps a good thing in the long term. But you know, we're not looking for huge amounts of detail associated with this. Really, our recommendation for modeling a Firestop in the opening is just so that it drives you know, a different line item within the COBie data set. So if that's part of the architect's model or it's part of the subcontractor's model, I don't think matters too much, provided the data for it is correct and that's clear and it's prescribed throughout the process.
Yeah, great. Thank you. It seems we are almost, I think we've covered pretty much all that we can cover now out of the questions. If you didn't get an answer, we can get back to you offline after the webinar, so don't worry about that. I think we are also pretty much, we've used our time that we had for today. So yeah, thank you so much once again, both of you, Alex and Brent, for the great presentation, great demo, and all these answers you had for us.
You're welcome. Thank you
Good
for having us.
questions. Thank you.
Cheers. Thank you.
So this time I don't have you save the date for our next webinar, since we are going to have a bit of a summer break now, a couple of months, and then get back with our webinars in autumn. So we will share the autumn first webinar of autumn details a bit later. Keep an eye on your inbox. We will send you an invitation email later in the summer or early autumn. Yeah, so otherwise it was a pleasure again. Thank you all online. Thank you, Brent and Alex. Thank you, Lauri, and have a great summer, everyone.